Good morning. My name is Tabitha, and welcome to our class again, online session. So today we're still continuing with our three-dimensional shape. So what we'll be looking at today is faces, edges, and vertices of a three-dimensional shape. So by the end of this lesson, you should be able to identify faces, edges, and vertices of three-dimensional shapes. All right, just to quickly remind ourselves, what is a three-dimensional shape? All right, three-dimensional shapes are solid and they have length, width, and height. All right, so with these shapes, they have three characteristics, mainly a face, an edge, and a vertex, which we'll be focusing on today. So if you're looking at this image here, it has got pointers, all right? The first one here is edge, and it's pointing right to this line. Okay, if you can be able to see that it is pointing straightly to this line, that is an edge, and the face is pointing on this surface here, which is the flat area, which is the face. All right, and here the pointer is pointing right to this corner, and that is called a vertex. All right, every corner on this object will be known as a vertex, or if it's more than two, it will be vertices. All right, so now let us give a clear definition of what a face, edge, and vertex are. All right, a face is the side of a solid shape. It usually means a flat face. Also, the base of a shape is a face. Okay, the base of a three-dimensional object is also a face. All right, now looking at the edge is the shape where two faces meet. Where two faces meet, that is called an edge. All right, an edge can be curved or straight. It can be straight or curved. All right, now at a vertex, what is a vertex? A vertex is a point at which two or more lines meet in an object or shape. A vertex is a point at which two or more lines meet in an object or shape. All right, as we've seen on the previous slide, on that picture that we had, that box that we had, the line, we saw that the line was an edge, and the face was that flat surface or that flat area, and the vertex were the corners of that box. All right, so here, since last week you already started with prisms and we're able to identify what a prism is and also give a definition of a prism. So today I want us to start with this exercise. Please remember to switch off your camera. Do switch off your camera, otherwise you will be kicked out of the session. So please do switch off your cameras. So yes, as I was saying, last week we learned what prisms are, and we're able to identify the two opposite sides of the prism, which would be polygons. So this exercise that we're going to do, we are going to give the name of the shape of the two shapes, or rather the two opposite faces that are the same shape and size. We'll give the name of those shapes, and also we'll give the number of faces for each prism, number of edges, and also number of vertices. All right, I'll start with the first one. Okay, so prepare yourself for the second, third, fourth, and the last one. I'll start with the first one. So the first one, we have a triangular prism. Why am I saying we have a triangular prism? Because the two opposite sides, this shape here and that shape here, they are opposite faces. They have the same shape and the same size. And these are triangles. Hence, I am able to say that this is a triangular prism. So we have two triangles here and the number of faces. Okay, now let's count the number of faces. We already have two opposite sides so that we know those two faces. Then we have 3, 4 with the base and 5 with the side. So we have 5 number of faces, number of edges. All right. As we said, the edges are the lines where the two faces meet. So here we go. Let's start with this one. It's 1, 2, 3, and then we come right at the top. 4, 5, 6, 7, and then 8, 9. So we have 9 number of edges. All right. The last one is a number of vertices. All right. We've just said that the where the two lines meet, will be our vertex. So now we're looking for the number of vertices. That corner there, that's 1, that's 2, 3, and this one 4, and this one here 5, and this one there 6. So we have 6 number of vertices. So remember we said the name of the two opposite faces is triangles. And then the number of faces, we have 5 faces. Number of edges, we have 9 edges. And the number of vertices, we have 6 vertices. All right. So if you are ready, you can always write on the chat box. If you are ready, you can always write on the chat box. For the second one, you can just write the two opposite faces. What is the name of those two opposite faces which have the same shape and the same size? Or you can raise your hand to give an answer. So if you are going to give an answer just like I did, you are first going to tell us the two opposite faces, the number of faces, number of edges, and the number of vertices. Okay, I see there's one on the chat box. All right, I see you asking me to go back to the meaning. All right, you can always go to online when we are done. You can go to Africa Teen Geeks and then you'll be able to find this video there. And also you can go on YouTube, you'll be able to find the meaning there. All right, so if there's anyone who wants to attempt an answer number 2, give us the two opposite faces, number of faces, number of edges, and the number of vertices. All right, for the YouTube link, you'll be able to see, if you just type when you go to YouTube, Maths grade 6, faces, edges, and vertices, you will be able to get it. But now, can I have someone that is going to answer here? Can I have someone that's going to answer for us? All right, Njabulo has given us an answer, and he says it is squares, and that's correct. The second one, looking at these shapes here, all right, and there's the second one, all right, that's two opposite squares. Now the number of faces, the number of edges, and the number of vertices. Okay, Ndubo says it's 6, 12, 8. Charles says, all right, 6 faces. Okay, everyone is saying 6 faces. Masodi as well is saying 6, 12, 8. So it basically means the number of faces, number of edges, and number of vertices. Right? Yes, everyone is correct. We have 6 numbers for faces, 12 numbers for edges and 8 for vertices. All right, now can we move on to the third one? I see everyone has got that one right. Everyone that's typing here, we have the correct one. Okay, Jaden is saying 7 vertices. 7 vertices for which one, Jaden? Which one are you referring to? Because we are still busy with the second prism, which is a tube prism, this one. So we said here we have squares, and we said the number of faces is 6 faces, 12 number of edges is 12, number of vertices is 8. Right now we're looking at this one. We're looking at the third one. What is the name of the two opposite faces? Firstly, give me the name of the two opposite faces, and then you can give me the number of faces, edges, and vertices. All right, it's rectangle. Yes, everyone has that right. It's rectangle. Thank you so much, Tristan, Mukomo, Jabulo. Thank you for your answers. All right, I see everyone is answering. We do have rectangles. That's correct. Now, can we please, when you write, write the 3 numbers next to each other, so that I can be able to know the first one will be for faces, second one will be edges, and the third one will be for vertices. All right, number 3, Ihsan Kennedy saying 6, 12, 8, and that is correct. And also Nduwode saying 6, 12, 8. We have the same numbers with the square and the rectangles. We have the very same numbers, 6 faces, 12 edges, and 12 vertices. All right, we move on to number 4. We are already given the name of the two opposite faces. We are already given the name of the two opposite faces, which is pentagons. So all we have to do is to count faces, number of edges, and number of vertices. So if you can just write the 3 numbers in that order, the faces, the edges, and the vertices, then we can be able to move on. This is going to be a very quick lesson. Okay. Trisha says it's the last one, 7 faces. All right, yes, 7 faces, but what about the number of edges and the number of vertices? 7 faces won't play as well, but can you also, like Jaden has done for the previous one here, where Jaden wrote 6, 12, and 8, can we do the same thing for the pentagons? Can we write those 3 numbers? If it's 7 faces, write 7 and the number of edges and the number of vertices. I see we've already got that one correct. Yes, it is 7 faces. Can we move on to, okay, Njabulo is saying 5. It is 7 faces, Njabulo. It is 7 faces. Yes, it has got 5 sides. The number of sides is 5, but remember we have these 2 opposite ones, right? It is pentagons because it has 5 sides. There's a difference between the sides and the faces, okay? These are the sides, 1, 2, 3, 4, 5, yes, 5 sides. However, now we are counting faces, and in our definition, we did say that it is a flat face. It is a flat face, normally refers to a flat face. And we also said that the base of that shape, the base of a solid is also a face. So we counted these 2 opposite ones. The 2 opposite pentagons, we count 1, 2, and the 5 sides, so that gives us a 7. Okay, Njabulu? So that is why we have a 7 and not a 5. All right. Some are saying 7, 16, 10, and some are saying 7, 15, 14. All right, there's a slight difference. Can I just have the last one? Zamile is saying 17 edges. Jaden, 16 edges. Charles, 15 edges. All right, Charles has got the correct answer. Charles has got 7 faces, 15 edges, and 10 vertices. So for number 4, the pentagons, it is 7 faces, 15 number of edges, and 10 vertices. Okay, so the correct one there for the edges is 15, not 16, and the number of vertices is 10, not 14. Okay, so number of faces is 7, number of edges 15, and number of vertices is 10. Right, can move to the last one. The last one, we have been given the name of the 2 opposite faces, which is hexagons. So now can we have the number of faces, number of edges, and the number of vertices? Remember, you do count at the base and the top as well as faces. All right, so can we have the number of faces, edges, and vertices for the last one? 8 faces, yes. 18, Dora says it's 8, 18, 12. All right, everyone saying 8 for the faces, that's correct. And JD as well, 8, 18, 12, that is correct. That's the correct answer. We have 8 faces, 18 edges, and 12 vertices. Thank you so much for your participation. Now let us move on to our next slide. Thank you so much for your participation. Let us move on now to our next slide. All right, now that we have identified the number of faces, number of edges, and the number of vertices, all right, now we're going to deal with nets. All right, the prism net. What is a net? A net is a flattened template which can be folded into a solid. A net is a flattened template which can be folded into a solid. Now it is easy to match a 3-dimensional object with its net if you know how many faces it has. Right? So as we have completed the number of faces, number of edges, and number of vertices, so we're moving on to our net. So we should be able, for this next exercise that we're going to do, be able to identify a net by matching the 3-dimensional object, by identifying the number of faces of the 3-dimensional object. Okay? So now let us move on to our next slide. Okay, here is an example. This one I've already written the name. Okay, this is a rectangular prism or a rectangular solid. This is a 3-dimensional shape. However, on the image here, we have a net. I was able to pick up that this is a rectangular prism because of the number of the faces, right? Remember we said a rectangular has got 6 faces, 12 edges, and 8 vertices. And we also know that it has the same numbers as the square. But now the difference between the rectangular prism and a cube prism, it is because a cube prism, all the sides are equal, or all the faces are equal. It's the same shape and size. But with the rectangular prism, we have different sides. There's 2 opposite sides that are the same, and the 4 sides are equal. So that is why I'm able to pick up that this is a rectangular prism, looking at the shape of the faces. The shape of the faces is my guide, and also the number of the faces. All right, so let's move on to our next slide. All right, a pyramid. Going to look at a pyramid. A pyramid is a polyhedron that has a base, which can be any polygon, and 3 or more triangular faces that meet at a point called the apex. These triangular sides are sometimes called the lateral faces to distinguish them from the base. All right, remember we said a pyramid is a polyhedron that has a base which can be any polygon, right? It can be any polygon. Now the sides, these triangular sides are sometimes called lateral faces so that we can be able to distinguish them from the base, because sometimes the base can also be in a triangular shape. So for us to be able to identify the base, we sometimes call the sides the lateral faces. All right. We spoke of an apex. This part here is an apex, the top part there where the faces meet. That's the apex. And this part here is the base. Okay. That's the base, and we move on. All right. Now we have our little exercise. Can you identify the different shapes? These are nets of different 3D shapes. These are nets of 3D shapes and different shapes. So if you're looking at these shapes, looking at these nets, can you be able to identify the 3D shapes from looking at this net? All right, I am going to offer you a table, or rather a box with the names and also the shape. So let us move on to our next slide. All right, here it says match each of the nets below to the correct object name in the box below. All right, on the left, we have our nets, and then on the right, we have the name for the three-dimensional shape. So when we answer, we will answer A, you will write A, and the name of the prism or a pyramid or a three-dimensional shape, you will write A. This is the name B, the name C, the name. Okay, I see. Okay, we have B, a rectangular prism. We have a cube. Yes, that's correct. Everyone is right. We have C, a pentagonal prism. That's right. Okay, there's one Adriel, who's raised a hand. Okay, everyone is saying A is a cube. A is a cube. That's correct. And B, okay, can we write them in order, because some are jumping to K without having answered E, F, G, and H. All right. All right. Kobe, we have 3 hands that are raised. Can we have one that is going to answer C, D, and E? From those 3 that have raised their hand, can we have one?
Hello, it's
Hi.
A is cube, B is rectangular prism, C
Yes.
is pentagonal prism,
Yes.
D is hexagonal prism, E is pentagonal based pyramid, F is triangle prism, G is square based pyramid, G is hexagonal based pyramid,
G or H?
H.
Yes.
I is hexagonal based pyramid,
Uh-huh.
J is triangle based pyramid, and K is a cylinder.
All right. Thank you so much. Those are all the correct answers. Thank you so much for your answer. I would also like to check on the chat box if there's anyone with a different answer. All right, cube, prism, pentagonal. Right, it seems that everyone has the same. the same answers because I'm looking B, I have H, E, I have A, I have E, and there's lots of other answers. So can we see that now, since we have done the number of faces and also the number of edges and the number of vertices, and also being able to identify the two opposite sides, has helped us in identifying these nets. So if you do know the number of faces and also the two opposite sides, it will help you to identify a net. All right. So thank you so much for your answers. Yes, they're correct. A is cube prism. B is rectangular prism. C pentagonal prism. D hexagonal prism. E pentagonal pyramid. F is triangular prism. G cube. What's this? A square pyramid, hexagonal pyramid, octagonal pyramid, triangular base pyramid, and K a cylinder. All right. So thank you so much for your participation. I see everyone had all the answers right. Everyone that wrote on the chat box had their answers correct. Okay. All right. Now this is the last slide. Please do switch off your camera. Can you switch off your camera? Otherwise, you will be kicked out of the class. All right, so we're now looking at pyramids. All right, so pyramids that have only triangular faces are called triangular pyramids. Pyramids that have only triangular faces are called triangular pyramids. Triangular pyramids can have many different shapes. All right, triangular pyramids can have many different shapes. A triangular pyramid whose triangular faces are all the same shape and the same size is called a tetrahedron. We did mention this earlier on in our previous slide, that if the faces of the pyramid are all the same shape and the same size, that particular pyramid is called a tetrahedron. Now, all tetrahedrons have the same shape. Okay, they have the same shape. All right, this is the end of our lesson. As I said, that this will be a very short lesson. So what we should remember about today's lesson is that we learned about three-dimensional objects and their characteristics, which are the face, the edges, and the vertices. All right. So what must we take home, or must we take away from this lesson, is that if we know the number of faces of a 3D object, it is easier to identify a net. All right. And also we must remember that if a pyramid has the same shape and same size with the sides and the base, that is called a tetrahedron. All right. Switch off your cameras, please. I know that we have come to the end of the lesson, but please do switch off your cameras. All right. We don't have a homework for today, but definitely tomorrow I'll give you one. And what I'll say about a homework when I give one, remember I gave you a homework last week and I asked you to do a solid shape from the net. Can you please scan those, or rather take a picture and send it to my email? Take a picture and send it to my email, and also the homework that you completed where you were matching the 2D shape with the net. Please take a picture, send it to abongolo@gmail.com. Send it to abongolo@gmail.com. Thank you so much and bye.